Okay, we are focusing on EC2 and data transfer costing sort of details in this short presentation, right? Uh, all right, let's go through quickly. Some of them are we already gone through. So, introduction to AWS EC2, availability zones and regions. So, core AWS infrastructure component EC2 is Elastic Computing Cloud. So virtual servers in AWS Cloud. Uh, we call availability zones isolated data centers. We already know regions are geographic area containing multiple availability zones. So why EC2 matters with these components? So we're going to achieve high availability, disaster recovery, scalability, and finally the cost optimization with the EC2s, right? Okay, so basic concept regions and availability zones with EC2, right? Uh, each EC2 instance runs in a single availability zone, right? And auto scaling can distribute across availability zones, right? If not instance failure, so availability zone dependence in EC2 always, right? Okay, so let's have a look at what are the EC2 deployment models across availability zones and regions. So as we discussed, so EC2 instances can be deployed in a single availability zone, right? Deployment in one availability zone, example in one region, one data center, risk availability zone failure equal instance failure. So use cases, non-critical workload. So if you don't want to spend money on some sort of service, use single availability zones, but they should not be very critical workloads. So second option, multi-availability zones. That means EC2, high availability, how it works. So we deploy in a region across the multiple availability zones, right? And we use tools like Elastic Load Balancer and auto scaling group feature. So Elastic Load Balancer distribute traffic uh, across these instances, and auto scaling is scaling EC2 instances across multiple availability zones uh, with the demanding loads, right? User case, this case is production apps. So you use 99.99 plus uptime in this case, right? Okay, the third and most expensive option is a multi-region EC2. That's usually for disaster recovery, right? How it works, deploy in multiple regions, right? Tools, right? So you use Route 53 failover with AMI copies. You can have Amazon messing images copies, right? Use case, mission critical applications, but you need to make sure it's really a mission critical. Otherwise, this option will cost you a lot of money, right? So in here, you can see it's like in a bit of a diagram. Some of them are overlapping, but I think deployment model, single availability zone, right? So single availability zone, simple but not failover, no failover capability, lowest cost, single point of failure, right? Just like in our on premises. If something fails, it fails, right? And Second option here, a single region, multiple availability zones, zone failover, right? So you can have multi-availability zone redundancy. You got data center redundancy there, automatic failover within region. It's sort of a balance cost reliability. So you can add a load balancer to distribute EC2 instances in multiple availability zone. If one of them goes, the other one is still available for providing the service. So the third one, multi-region. Multi-region means two regions or more. So highest availability, disaster recovery, you can use for disaster recovery, geographic redundancy, and highest cost. So what it does, you got here in a region fail over covers multi-availability zone, and then sorry, yes, and then a regional total fail over covers with the primary and secondary regions replication, and then you use Route 53 to fail over. But consider in whatever in the question they ask, you need to consider the highest cost, multi-region. You can get everything but highest cost. All right. So let's go quickly key EC2 features and their availability zone region behavior, right? So EC2 feature, availability zone scope, region scope, and some sort of nodes, right? So EC2 instance, one instance, EC2 virtual server, scope is single availability zone, right? Region scope is in a region, must manually launch in another availability zone for high availability. If it's only in a one availability zone, it's a risk of failure, right? Elastic block storage volumes, single availability zone, but you can do regional snapshots attached to instance in the same availability zone. Snapshots restore to any availability zone, right? EBC volume. AMI, machine images, regional, can copy across regions, right? Used to launch instance in any availability zone in the region. So you can copy them across regions, right? And another one is elastic IP, right? Public IP. Scope is regional, right? No cross region. So no cross region must reassign it moving instance across regions. If you move into another region, your instance, so you have to reassign because Elastic IP is a regional service. It won't available in a different region. Placement groups, we putting a cluster of PCs, right? We need fast, low latency, and sort of more power, right? So for getting low latency, placement groups need to be in single availability zone, right? In a region, or cluster placement groups need all instance in one availability zone for low latency. You need to remember this one, right? Auto scaling group, right? Auto scaling group in a region, multi availability zones, right? And you can it's a regional service, right? Distribute instances across availability zone for high availability, right? Understanding the scope and limitations of EC2 features across availability zones and regions is crucial for design resilient architecture. Features like EBS volumes are availability zone specific, while AMIs can work across regions after copying, right? So need to understand the cost and high availability with these services, right? All right, so let's talk about high availability strategies for EC2, right? You can use these strategies, right? Auto scaling plus multi availability zone. So you can use active. right? So what it does, deploy uh, auto scaling group across multiple availability zones, right? Example, you can put them into a different data centers, right? And attach application to a load balancer to distribute traffic. So if you got three instances in a multiple availability zones, you can attach these three into a load balancer, right? If one availability zone fails, availability auto scaling group launches replacement in other availability zones. So automatically will launch another instance in a available other availability zone, right? So user case production application requiring 99.99 uptime. So that is how you getting a high availability for EC2 instances, right? And as we discussed previous video, pilot light disaster recovery, so warm standby, right? Primary region, running EC2 instance with full capacity. So we running actual primary service with a full capacity, but we got a disaster recovery region, minimal EC2 for footprint with latest in AMI ready. So we got a sort of a model type footprint machine running in there. And on failure, it will be scaled up in disaster recovery region using ASG. Uh, Automatic scaling group will make it to size of primary when a failure occurs, right? So in these warm standby instances, recovery time is about 30 minutes to 60 minutes. And then another option, but this might be a more costly solution. So what it does, you deploy identical stacks across regions. So you put US East one and EU West one, right? So one region you put the same thing in another region, right? And then use Route 53 latency based routing for traffic distribution, right? Sync data with Aurora global databases or DynamoDB global tables, right? This sort of setup is recovery time is near zero, instant failover. Mostly you want a customer won't be able to see that it's failed, but spilled over with the recovery time. So here is a graph, EC2 recovery times by high availability strategy, auto scaling plus multi availability zones, about less than 10 minutes, right? And then high availability strategies, pilot light DR method. That's a warm standby. That's up to 60 minutes. And then a multi-region active setup. Active setup. You can get it from less than 1 minute. But uh, think about these services. They're going to cost you more money. All right. Um, let's have a look at advanced networking configuration for regional failover, right? How do you achieve this regional failover, region to region, right? AWS multi-regional architecture with failover. This is sort of right um, example setup, right? So you got a EC2 instance, right? And it's running RDP databases as well as S3 bucket, right? And then you got a cross-region replication, US to West, secondary region, right? The same thing running in here. But you have Route 53 DNS failover enabled. They checking health checks, right? And you got a DNS through DNS failover routing, right? And then you got a global accelerator, right? So anything happened, they going to be this region going to become a primary region and to become a fail lower if anything happened to this region. So key networking component for this setup, you need a Route 53 to be DNS based routing with the health checks. So health checks checking a constantly health check and a global accelerator, static IP address with the traffic distribution, right? We're going to talk about this one in the future, right? And then you need a VPC peering region to region connectivity. So it's peered network, right? And then you need a transit gateway, network transit hub for cross region routing. So choose cross region routing. So you got to, as we explained in a previous video, we have different regional failover patterns, right? Active, passive, right? One is primary and standby regions, and then the active workload distributed across regions. So that's the most expensive. And then DR, pilot light, co-infrastructure in standby, right? And then you got a warm standby, right? That is scaled down active replica, right? Sort of scaled down replica is for a warm standby setup, right? So AWS regional failover configuration latency was through output, right? Um, so this is measurement value, right? Through output and with the latency. So Route 53, right? To global accelerator, your transit gateway, right? And direct connect. So this is how you use these ones, helping you uh, to through output versus latency. So implementation considerations, configure cross-region VPC endpoint for services, right? Implement IP-based routing policies for seamless failover, right? So IP-based routing policies, and then use CloudFront to cache content closer to users, right? So CloudFront distribution is being used for giving less latency for users. Consider dedicated direct connect for predictable performance. So dedicated direct connect AWS direct connect. Dedicated one for fast, less latent setup, right? And then now we going to looking into disaster recovery options for EC2, right? Disaster recovery options for EC2. So multi-account, multi-VPC structure, right? So this advanced DRS strategy provide complete isolation between environments, right? Independent security control per account, right? Protection against region-wide failures, right? Um, so this is AWS EC2 disaster recovery strategies comparison, right? So so key DR strategies, right? So backup and restore, the lowest cost, highest RPO and RTO. So you backed up and you restore one of the point in to one of the point in time, right? Let's say you doing a backup, something you have backup for 30 days. So when something happen, you can restore from backup, right? It's the lowest cost, but it's not online, right? And then Pilot Lite, that co-infrastructure replicated in another region, right? Warm standby, scale down version ready, and it will be scaled up with the scale out, right? Scale out with the ESG when something happen, right? And then you can use multi-site. Multi-site is a full production capacity in multiple regions. So the most expensive setup, right? So this is giving us sort of a comparison strategies for AWS EC2 disaster recovery, right? So it gives you RPO, right? RTO, right? And relatively the cost, right? So backup and restore, actually, if you have a look, cost is less, but it has highest RPO and RTO, sort of more than 20 minutes, right? Might be a 30 minutes or something like that, right? So pilot light is the second one. Is a between you do have about 10 in between 10 to 20 in between pilot light, right? Pilot light is a core infrastructure replicated, right? And warm standby is scaled down version is ready in some other region, right? It has a sort of less RTO but more costly experience, right? Multi-site full production capacity running in another one, but cost is highest cost you get, right? And so that is here. Let's have a look disaster recovery options here in for EC2, right? That's a summary in a table. Let's have a look. So DR strategy, RTO, recovery time objective, RPO, recovery point objective. So how much data are you going to lose in that case? AWS tools used, right? Okay, backup and store. Recovery time objective is hours, right? It take hours, right? RPO, right? 24 hours. So daily backups you need to get from one of the daily backup, right? And this one you can use Amazon meshing images and EBS snapshots for block storage devices, right? Then pilot light, pilot light DDR method. So take 30 to 60 minutes, right? Minutes RPO data loss. You're not going to lose much data, so data loss is in minutes, not like hours, right? Asynchronous replication, right? So here you can use auto scaling group plus AMI copy. That means Amazon machine image copy to restore, right? Warm standby 10 to 30 minutes, right? And RPO is seconds, right? RDS replication, sort of like RDS replication. So you need to use auto scaling group plus cross region copies for restore in this disaster recovery option, right? So multi-region active. So these are not active. So this one is a multi-region active. So the recovery time objective is near zero, right? And RPO, right? Recovery point objective, you get nearly a zero data loss. And then you have to use Route 53 plus global DB replication, right? And then if you're looking into cost versus recovery trade-offs, as your recovery time requirement decrease, the cost of your DR solution increases. That means your recovery time, less recovery time objective, you got a more cost of your DR solution increases. You have to choose based on your application's criticality, right? And data transfer consideration, right? So cross-region traffic cost. So it costing $0.02 per GB if you transfer 1 GB from one region to another region, it costs actually a 0.02, uh, that means 2 cents, cost 2 cents, right? And then AMI EBS is not snapshot transfers incur charges, right? These ones incur charges as well, right? Compression can reduce transfer cost. We can use compression, right? So at the bottom, right? So you have this backup and restore, right? And this is the options, right? Pilot light, high cost, right? High RTO and RPO, right? Let me, okay. So then warm standby, right? And then you got multi-region active, right? And low cost and low RTO, RPO, right? So these are the things you need to consider uh, when you are considering what you want to do with your RPO and RTO, right? And then we're going to discuss common pitfalls and best practices for EC2 high availability and disaster recovery, right? Common pitfalls are in single availability zone deployment with no redundancy, right? And then another mistake is EBS volumes not backed up regularly, right? If you're doing it manually, it's not backed up, right? No cross-region EMI copies for disaster recovery. If you don't keep any copies, machine images in a disaster recovery, neglecting to test failover scenarios. You need to make sure your failover scenarios are working. Maybe check under 1 month time or something like, right? And then ignoring data transfer cost between availability zones, right? You're thinking this is a free service, it's not free. Whatever data transfer between availability zone cost as well, right? Uh, Regardless of what is the cost, so these are the best practices for high availability and disaster recovery. So use auto scaling group across multiple availability zones. That means the data centers. Enable automated EBS snapshot instead of manual ones. So you it's make sure you got backups when needed. Schedule regular AMI copies to a disaster recovery region. So you keep scheduling copied copies into another region, right? And then test failover scenarios quarterly. Quarterly means at least once in a 3 month time, right? And the balance availability zone was cross-region data transfer cost. So consider Azure calculator and see how the transfer cost affect you and do them accordingly, right? Testing strategy. Regularly simulate availability zone and region failures to validate your recovery procedures and make sure document recovery steps, timelines for each scenario. Make sure they're working. Can do that. Use savings plans or reserved instances for stable workloads. Consider spot instances for non-critical, interruptible workloads in your HA setup. So think about cost optimization when you are using high availability or disaster recovery, right? Real world example, multi availability on web applications. So production web service with uh, ALB, that means load balancing, right? Distribution traffic to ASG span increase, three availability zones. auto scaling group, right? With RDS, multi availability zone for database high availability, and weekly AMI copies to DR region to best practice, right? All right, so going to looking into AWS data transfer costs overview. We were talking about this high availability and disaster recovery, but what are data transfer costs? Right? AWS charges for moving data between different components of your cloud infrastructure. Right? Charges vary based on source and destination, depend on geographic location of resources. They are the costs are different from region to region, right? Varies with volume of data transferred, right? Key charging scenarios, right? So within the same region, between availability zone, cost occurs data transfer between among availability zones between different AWS regions. So different cost occurs between the scenarios. And then from AWS to internet egress, so it charges the data as well, right? Okay, so I believe this one is up to date, but you can check the data transfer cost going into AWS. So within region, that means cross availability zones, right? Cost is 1 cent per GB, right? And that means 100 GB transfer cost $1 per month, right? Let's say you transferring data in between two data centers. It costs you $1 per month per 100 GB transfer. And then between AWS regions, cost uh, 0.022 uh, 19 cents per GB, right? And normally, if you transfer one TB transfer, uh, cost $20 and 48 dollars per month, right? And to internet egress, that means data going out from AWS, right? 0.09, right? First 100 terabytes. So it cost 9 cents, right? And that means so if you have 50 GB egress and it cost $4.5 per month, that means 100 GB, $9 per month, right? This is for first 100 terabyte up to, right? The cost going to be changing, but these are just to know that this high availability and disaster recovery, when you're implementing them, it cost you other than the placing the services in different regions and availability zones, but it will cost you money, the data transfer cost as well to keep in mind, right? Then got the free data transfers and cost optimization tips, right? Free data transfers, right? Same availability zone transfers, right? So it EC2 to RDS in the same availability zone. If you place in the one EC2 instance and RDS in the same availability zone, there's no right. And inbound traffic uploading to AWS, right? EC2 to S3 using VPC endpoint. VPC endpoints use their internal backbone network, so you don't have to uh, uh, pay for that one. So if it's a VPC endpoint, that's internal. So This is what you have to think about cost of optimization strategies, right? Minimize cross availability zone traffic, right? Place related services in the same availability zone, right? Use VPC endpoints like scenarios, use S3 buckets and elastic file system, network file system, right? Reduce cross region cost, right? So S3 transfer acceleration, right? Or you compress data before transfer, right? uh, Lower the internet egress, right? Use cloud front, right? Cheaper rates, right? And direct connect for high volumes. If you have AWS direct connect, uh, use for high volumes, right? And some of the real examples like web app use cloud front with the same availability zone for backend. If you got the data or DS instance or something, just put that in the same availability zone so it doesn't occur, or it's an application server and data RDS you put in the same availability zone to make sure you got no data charges. So savings 40% plus on transfer cost. So got a savings on that sort of if you put in the same availability zone, right? Uh, that is sort of you can do these references. So actually, we discuss EC2 instance, how they going to affect how we achieve high availability uh, among availability zones and cross region, disaster recovery, and backup considerations, and how much cost occurs in when they place in the different zones and transferring and data transferring cost among them, right? And uh, the last, what I have to say is all depend on whatever asked from you with the resilient infrastructure, right? And what is the service, right? Is that mission critical, or you have to place the services according to what is your requirement to make cost less cost occurring, right? All right, guys, I believe this finish this today's presentation, right? See you guys from another video with another service soon. Until then, thank you very much.